The problem is from GATE 2016 mathematics paper, question number 28. The problem given is, let gamma be the triangular path connecting the points 0, 0, 2, 2 and 0, 2 in the counterclockwise direction in R square. Then I is equal to the circle integration over gamma sin x cube dx plus 6xy dy is equal to dash. So the NPTEL reference to solve this problem is lecture 36. Title of this lecture is Green's theorem from multivariable calculus by Dr. Sanjeev Kumar. He is from Department of Mathematics, IIT Roorkee. Even you can watch this reference video using this YouTube link. So now just look by just looking at this problem, we can easily see this is nothing but a straightforward application of the Green's theorem. Since we can, by just considering this as one function and this as another function, we can see this is nothing but integration m dx plus n dy. So that is nothing but in terms of Green's, by just applying Green's theorem, we have some formula for that. So here also we directly apply that formula. So given I is in circle integration over gamma sin x cube dx plus 6xy dy, where gamma is the triangular path connecting 0, 0, 2, 2 and 0, 2 in the counterclockwise direction. So firstly, let's look at the path gamma by connecting these 3 points. So then we get, by taking this as 0, 2, this 0, 0, so this is 2, 2. So the given triangular path is nothing but connecting these 3 points, origin, the point 0, 2 and the point 2, 2. But since it is given in the counterclockwise direction, we get the direction is in this path, in this direction. So by Green's theorem, we have the Green's theorem, which tells us that integration m dx plus n dy is nothing but double integration dou m by dou x, sorry, dou n divided by dou x minus dou m divided by dou y dx dy. This is Green's theorem. So now by simply applying this theorem, we get the integration, the circle integration I is given as the circle integration over gamma sin x cube dx plus 6xy dy is the double integration dou n divided by dou x. So dou divided by dou x of 6xy minus dou divided by dou y of sin x cube dx dy. So, but the question here is, what are the limits for these two integrations? We can easily see that the first integration is with respect to y and the second integration is with respect to x. So for the limits for x and y, so by just looking at this graph, we can easily see that the limits of firstly the limits for y, since the first integration is with respect to y, so I'm just considering the limits for y. So we can easily see that the values of y is ranging from 0 to 2. We can see that the total value of y is in between the two lines y equal to 0 and y equal to 2. So I'm writing the values of y is from the limits for y is from 0 to 2. But coming to the limits for x, we can see that x is not running from whole from 0 to 2. It is running a little less to the whole values from 0 to 2. And in fact, it lies in between the two curves y equal to 0 and y equal to x. So I can write the values of the limits for x are from 0 to y. Since you can see this is the line y equal to x and this is the line y equal to 0, and the values of x are lying in between these two lines. So the limits for x are nothing but 0 to y. So hence in total we get this integration now by standard methods as integration 0 to 2, integration 0 to y. This is 6y dx dy, and hence this as integration 0 to 2, and this is 6xy over the limits 0 to y dy, where these limits are for x. So we get this as integration 0 to 2 6y square dy, and this is nothing but 6 times y cube divided by 3 over the limits 0 to 2, 0 to 2, and hence this is 2 times 2 cube, that is equal to 16. Hence the answer is 16.